Alright guys, welcome to video number 3, and what I'm going to show you in video number 3 is how to use NormsDist distribution. In other words, how to calculate probabilities from a standard normal distribution. What I'm going to do is work through the 3 applications on page 5 of the bootcamp lesson number 3 notes. So if you take out bootcamp lesson number 3, continuous random variables and the normal distribution, turn to page 5. I'm going to work through those 3 examples or applications. Alright, the first of these says, alright, let's suppose that daily production is normally distributed with a mean of 300 units and a standard deviation of 25 units. You want the probability that today's production will exceed 350 units. Alright. Our tables are in terms of z values, not x values. So I have to turn these production figures, these x values, into z's. Alright, I'm interested in an x value of 350. To turn that into a z value, I subtract the mean, divide by the standard deviation, and I find that the z is equal to 2. What that means is that if I have production of 350 units, I'm 2 standard deviations above the mean of 300. Now, in terms of looking at probabilities, if I have an x value of 350 units and I want the probability of getting something greater than that, that's the same as finding the probability of a z value that's greater than 2. The problem is NormsDist distribution gives me lower tail probabilities, the probability of getting something less than a value. I want an upper tail probability. How do I do it then? Well, I'm going to manipulate the system. If NormsDist distribution is only going to give me a lower tail value, I don't want to plug in 2, because then I would get the probability of getting a value less than 2. What I instead can do is plug in a z value of minus 2, and because the distribution is symmetric, the probability of getting a lower tail, a value less than minus 2, is equal to this upper tail probability of getting a value greater than 2. Right? So let's go to Excel and let's find the probability for a z value of minus 2. In Excel, all I have to do is use my formulas and my f of x, and what am I going to use? Statistical formulas. So statistical, and I know these are alphabetically arranged. I want NormsDist distribution. So scroll down to the ends. I find NormsDist distribution. And notice the description. Returns the standard normal cumulative function. Has a mean of 0 and a standard deviation of 1. Yes. Cumulative means it's returning the probability up to the value z you give it. In other words, a lower tail probability. Alright, NormsDist distribution. Okay. Now what does it want? The z value. And remember, I want the z less than minus 2. It's going to give me a probability. It's already here, 0.0227. Okay. And I have 0.02275 times 100 is 2.275%. And if we go back to our application, we have a probability of 2.275%. The area in the lower tail is equal to the area I want up here in the upper tail. Alright, that's application number 1. Application number 2. Suppose that the average number of minutes required for a production worker to complete a task is normally distributed with a mean of 8 and a standard deviation of 0.6. calculate the probability that it will take less than 7.5 minutes to complete the task. Well, again, these are x values. I want to convert these into z's. To do it, again, let's subtract the mean. Let's take 7.5, what we're interested in, minus the mean of 8, divide by the standard deviation of 0.6. That gives me a z value of minus 0.833. Now this one's easy. What does that mean? It means that a value of 7.5 minutes is 0.83 standard deviations below the mean of 8. Well, in terms of our diagrams, I'm saying that a value of x equal to 7.5 is equivalent to a z value of minus 0.833. 7.5 is 0.833 standard deviations below the mean. So, to find this lower tail probability, the probability that I have an x less than 7.5, I want to find the equivalent probability of having a z less than minus 0.833. And the good thing is, NormsDist distribution gives me that probability directly. It gives me the lower tail. So all I need to do is go to NormsDist distribution, plug in minus 0.833, and I'll have the probability. Let's do that. Going to Excel, deleting what I had earlier. F of x, NormsDist distribution, statistical's already there because that's what we're using now. I go to NormsDist distribution, okay, and I plug in my z value of minus 0.8333. Okay. I get a value of 0.2023 or 20.23%. And if I come back, 20.23%, that's the probability for application number 2. Alright, moving on. Application number 3. Suppose that the number of customers visiting a store per day is normally distributed with an average of 1,200 customers and a standard deviation of 250. What is the probability that the number of customers will be between 1,000 and 1,500 today? Alright, I have two values now. Since I have two x values, 1,000 and 1,500, I need two z values. So, converting the lower z of 1,000, or converting to a lower z, using the x value of 1,000, I end up with a z value of minus 0.8. And x of 1,000 is 0.8 standard deviations below the mean of 1,200. Converting the x value of 1,500 into a z, I take the x, 1,500, minus the mean, divide by the standard deviation, and it tells me that an x of 1,500 is 1.2 standard deviations above the mean. Okay. Now, in terms of diagrams, we want this probability. I want the probability that my x value, centered at the mean of 1,200, is between 1,000 and 1,500. That's equivalent to going to a z-table or a z-distribution and finding the probability that we have a z between minus 0.8 and plus 1.2. Now there are several ways I could do this. I could go into NormsDist distribution, find the probability of getting a value less than 1.2. That would give me all this lower end because it gives me lower tail values, and then subtract out the probability, the white area, of getting a z less than minus 0.8. That'll work. The way I did it in the notes though is to say, look, we have a probability of 1 under the whole curve. Let's take out the probability of getting a z less than minus 0.8, take out that white area, and then let's take out the other white area, the probability of getting a z greater than 1.2. Now we've already seen that the probability of getting a z greater than 1.2 is the same as getting a probability of a z less than minus 1.2. So I need to go to my normal table. I need to find the probability of getting a z less than minus 0.8 and find the probability of getting a z less than minus 1.2. Let's do that. I go back to Excel. I'm going to find the probability of a z less than minus 0.8, statistical, NormsDist distribution. I'm going to find the probability of getting a z less than 0 minus 0.8. Okay. That probability is 0.2118 or 21.18%. The probability of getting a z less than 1.2, minus 1.2, I go to f of x, statistical, NormsDist distribution. Okay. This time I'm going to plug in a value, remember, minus 1.2. That probability is going to be 11.5%. 0.115, 11.5%. All right. We go back to the application, do the math. So our probability is 1 minus the 0.2119, this lower tail probability, and minus 0.115, this upper tail probability, and we get an overall probability of 0.673. That means there is a 67.3% chance that the average number of customers will be between 1,000 and 1,500 on a given day. And that's the end of video number 3.